right, welcome to another Shadow. My name is Robert Sharp, and I will be creating a Stable Diffusion interface for inclusion in the Scribble Stadium app. All right, so I know that we need some requirements straight away, so I'm going to start there. Requirements. T. Earl, are you familiar with Python?
A little bit, not, just kind of scripting and notebooks, not building projects.
Oh, okay. Well, this will be awesome for you then.
I'm pretty excited. Yeah.
So let's see, what else do I need? Actually, I might not even need .env right away. Let's skip that one for now. I need
The
diffusers.
requirements are like, these are like our dependencies.
Yeah. It's one way to set up the dependencies for Python. It's not the only way, but it's my preferred way. It's also the built-in, most simple, most direct way, which is why I like it. There's some libraries that you can use like poetry and stuff, but I don't know, you have to buy into the whole ecosystem to use something like that. And
Hmm.
I just want something simple. I can define my dependencies. I can specify versions if I want to, or I can
Hmm.
rely on pip, which is the built-in package manager for Python, to handle that for me. And that's typically what I do during development. Once I go to production, I pin the versions to known working versions. But during development, I actually prefer getting daily updates to all of my dependents. It can be a little hair-raising if something goes wrong, but it's pretty easy to pin to a previous version if something does happen.
Got it.
So let's see, we need diffusers. That's the Huggy Face library for Stable Diffusion. We also need PEFT, which is the library that enables LoRas. We should also grab Accelerate. My fingers are cold. I'm typing so slow.
Copy that. Where are
All
you
right.
at, Robert?
I'm in Oregon, Southern Oregon,
Oh, okay.
about 50 miles away from the California border.
Gotcha. Copy that.
Yeah, I love it here.
Awesome. Awesome.
All right, so I think this will get us started. And let's go ahead and make a Python package called app. We might restructure this later, but for right now, this will work. And then we need a main file. And what I want to do is create a class called ImageKit.
Okay.
And right now, I'm just going to stub out a few things. So in this class, we're definitely going to need the Stable Diffusion pipeline. So let's see, oh, it might help if I go ahead and install my dependencies so that I get help from my IDE for autocomplete. Yeah, let's do that next. So what I like to do, and this is my own personal thing here,
Hmm.
is to make an install script. And what this is going to do is do pip install. And you can do this from the command line, but I like to have a script that I can just run when I'm ready to do the installation. So pip install dash dash upgrade, and we want to upgrade pip setup tools and wheel.
Hmm.
These are the three base packages in Python that take care of installations and dependencies and all that kind of stuff.
Gotcha.
In addition to that, we want to install the requirements file, or the dependencies in the requirements file.
Okay.
So I'm going to tack on a little R and the name of the requirements file. Then I can run
What's
this.
the R flag is what's the R flag doing?
Oh, this specifies a file of dependencies to install.
Got it.
Yep. And this file can actually be anything, but it's R because typically this is called requirements.txt. So
Copy.
the R stands for requirements.
Okay, got it.
And then what I can do, can you see the pop-up?
I can. Yes.
Awesome. I'm going to click run install.sh, and my terminal is going to open and do all of the necessary installations.
Got it.
And I am going to wait for it to actually finish completely before I continue. And the reason for that is because I want my IDE to autocomplete stuff for me.
Okay.
Recently, I turned on the AI assistant in PyCharm, and I'm not terribly happy with it. I think I might turn that
Mm,
off.
okay.
I don't know. I guess it would help if you're learning Python and you want to see an example of code, or if you wanted to do stuff like that. But
Sure.
as an experienced developer, it's actually getting in my way.
Yep. I think a lot of AI products are kind of at that stage right now.
Yeah.
Or really helpful for beginner and sometimes slows down more advanced people. Yeah.
Yeah. So we're going to import diffusers, and more specifically, we're going to grab the Stable Diffusion pipeline. My goodness, there's a lot of them. I want this one right here. All right, that's the main piece of the puzzle, where you will also need torch. And we'll import the rest of the stuff as needed. So to start off, I want to go self.pipeline equals Stable Diffusion from pre-trained. The autocomplete did not give me the correct model, but that's okay. We could use this one, but I want to use 1.5. Oh, and we don't need self here because this is just a class variable. Let's see, I want SD legacy slash stable diffusion. No, I don't want XL. Let's close. I want 1.5. Okay. So this is the classic 1.5 model from Runway. The and what this is doing is accessing the model from Hugging Face, where many of the models are available for us to use.
Okay.
It's SD legacy because Runway ML is now kind of defunct and their repo is deprecated, but somebody made a handy copy here for us.
Gotcha.
This is actually quite an old model. This is like a 3-year-old model, which is
Okay.
amazing. I mean, it's like how quickly things evolve in this space. It's mind blowing.
Mm-hmm.
Okay, so there's a few other things that we need to define here. I want to define a device, and normally for Stable Diffusion, I use a CUDA machine. Today I'm on my Mac, so what I want to do is MPS instead of CUDA. I'm going to
Okay.
put a little note here. Change to CUDA prod. The server that we're going to run it on is going to be hosted at RunPod. I'm not sure if you're familiar with that, but
I am not.
it's a way to rent a GPU server, but you're only paying for the time that you actually use it, right?
Okay.
So it's not like the AWS setup where you get bare metal and you pay for it 24/7.
Yeah.
It's a much more cost effective way to go. There is a little bit of a delay when your instance spins up, but it's only
Sure.
like 10 seconds. I mean, it's fine. Let's see, what else do we need? Yep, that's good. Pipeline to device. That will actually enable it for us.
Okay.
I don't want attention slicing. I'm not sure why it suggested that. Let's go ahead and play with it this way for now. The other thing that I want to set up is a call method. And it will take a prompt as input, and we're going to specify the type as a string. We're probably going to have other inputs too, but I know that one for sure.
Okay.
And let's see, I want a UID that will be used to create a unique name. So I'm going to use UUID4 in order to give us a unique ID.
Okay.
Also, this is an object. It's a BSON object, and I want it to be a string. So I'm going to go ahead and cast it to a string.
Ah, okay.
Okay, let's see. What is next? Eventually, I'm going to have some LoRas, but I'm going to skip that part for now because I just want to see the baseline output from this and then attach some LoRas to it that customize the style of the images as an iterative step. So
LoRas are
now,
like a training sort of. What are LoRas going to do?
yeah, it affects the style of the output image.
Gotcha.
Um,
Okay.
there's multiple different varieties of LoRas. Some of them capture character. Like there's one devoted to Spider-Man, right? And if you
Ah, okay.
give it a prompt about somebody sitting in a chair, it'll be Spider-Man sitting in that chair.
Gotcha.
That's one variety. We're not actually going to use that variety. What we're going to use is a style LoRa. Some of the different variants of that would be like a Van Gogh style. So if you give it a prompt, sunset on the lake, it'll make it look like a Van Gogh painting, even though maybe that particular scene was never done by Van Gogh.
Copy that. Okay.
Yeah. Yeah, let's go ahead and make the image. So I'm going to say image, and this might be something you've never seen before. I'm going to use star underscore. And this star underscore, well, this entire syntax is exactly the same as if I index into the images, right?
Uh,
The one benefit of doing it this way is that there is no opportunity to get that index number wrong.
huh.
It just
Okay.
takes the first thing and drops the rest of it on the floor. Now, in this particular case, I'm only making one image, so there isn't really anything in the tail,
Okay.
which, this second part of it is the tail. And this is using automatic unpacking from Python.
Gotcha. Okay. So it's
Yeah.
saying,
So
it's like a pattern match.
it's kind of like doing this, right? Where A is 1 and B is 0.
Got
It's
it. Yep.
very similar to that. Okay. But I'm using a wildcard for the second one. And if we had a whole bunch of numbers here and I used the star on the B, A would equal the integer value 1 and B would be a list of 055.
Copy that. Yep.
Okay,
Kind of
so the other detail here is the underscore, which represents I don't really want this thing, make it go away, Python.
got it. It's almost like a pattern match, and then you're not naming it, so you're just kind of saying we don't
Yeah,
care about this. Got it. Okay.
yeah, yeah. Okay, so we have our image. Did I get the syntax of that right? It's close. We do want to provide some other inputs to this, but I think this will work for the initial go. Last, we want to do image.save, and we need to give it a file name. So what I want to do is specify the UID.png, and I'm going to use a format string, otherwise known as an F string, to get that variable into the string for us. If you're not used to F strings, it's a fantastic way to, to formulate complex strings from variable values.
Got it. Yeah, yeah. I think
Right.
we
So
like
it just
interpolation.
unpacks that. Yeah,
Yeah.
interpolation, exactly.
Got it. We have, yeah, more familiar with it in Scala. Yeah,
Okay.
like an interpolation sort of thing. Okay, cool.
I've heard lots of good things about Scala. I've never actually used it though.
It's fun. It's fun. I would definitely recommend it. It's really fun when you get into it. It's really expressive,
Yeah.
like a really expressive sort of Java.
Yeah, it
It's
runs
really
on the
cool.
JVM. When I was playing with some projects on the JVM, I decided that Kotlin would be the way to go. So I started learning Kotlin.
Mm. I have not played around with Kotlin yet. So,
Kotlin is like Python for the JVM,
mm,
which is why I kind of gravitated towards it because a lot of the paradigms are exactly the same.
okay. Very cool.
The syntax is a little bit different, but yeah. All right, so this is the basic formulation that we need. Don't know why it did that. What I want is if name equals mate. There we go. And we want, I'll just call this Jen for right now. Image kit, Jen, a photo of a cat. Okay. We'll go ahead and run that and see what happens. I may have made a mistake somewhere, but it's all part of dev.
Copy that.
One thing to note is that I already have this model downloaded in my system, so it doesn't have to go through that step. Otherwise, the very first image would take quite a bit longer to do. So if you're following along, you may have to wait 3 or 4 minutes to get the model downloaded. Oh, that's fun. All right, all right, all right. Let's do a dog. So it produced a black image for us because for some reason it thought it was inappropriate.
Interesting.
Not sure what it did, but yeah, I'll have to figure out a way to handle that in production. There we go. We got a picture of a dog.
Cool.
Um, by default, this is a 512 by 512 image, which isn't quite the right size that we need. So let's go ahead and define the proper image size next. Width equals 480 and height equals 640. Not ready to define that other stuff quite yet. And we don't want a photo. What we actually want is a kid's drawing as a sketch in monochrome. And let's give an action for the dog. What should the dog do?
Chasing a ball? Or
Chasing a ball. That works for me.
all right.
The other thing I think we can change on this is this 50 iterations per image. I think we can get away with quite a bit fewer than that. 50 is great for photos, but we're doing something a little messier. This isn't terrible. It's in the right ballpark, but at the same time, it doesn't look like a kid drew it, right? It looks like a messy drawing from an adult who's probably had at least some artistic training. And we want to strip that away and make it look much more like a novice, like even pre-novice. But we're going to keep that image around. We're going to get rid of this one because it is just not at all what we want. And let's play with some LoRas next. So I want to create a directory for our LoRas. And this directory it's going to hold our LoRas, and the LoRas are actually kind of big. They're a couple hundred megabytes a piece. And I need to make sure that we don't try to post this to GitHub. So I'm going to exclude that LoRa directory, and I'm going to create a .getignore file. I have a preset here No duplicates, no comments, no empty lines, generate. And I'm going to open the .get_ignore file, go down here to the bottom and specify LoRas.
Gotcha.
Okay. We're going to handle the larger files a little bit differently when we go to production. For right now, this will suit our purposes well. So next, what I want to do, I have a couple of LoRas here prepared. I'll go ahead and copy those. And there we go. So I'm not sure which one of these is going to be best for our purposes, but they both seem to produce something close to what we want. We
And
may,
those LoRas came from also from Hugging Face?
they have tons of LoRas on Huggy Face. I actually
Yeah.
got this from another source called Civet.
Okay.
I'm not sure if these are available on Huggy Face or not, to be honest with you.
Are these LoRas specific to that model?
Well, kind of. They're specific to this model architecture.
Okay.
Okay, so it's actually a group of models that these LoRas work with.
Okay.
And they're all based on this base model.
Got it.
Like, there's fine-tuned versions of this model out there, and these LoRas would work with those too.
Perfect. Okay.
Yeah. So in order to set up our LoRas, we need to load the LoRa weights, and we need to set the adapters. Okay, so what I'm going to do here is go pipeline. Okay, wasn't load. Yeah, load LoRa weights. And here we're going to give it the name. And the first string is the file name, or rather the path to the file. And the second one is the adapter name, which we're going to use later in order to tweak how much of this LoRa is used in a particular image generation. Okay. So what I want to do first is define LoRa, oops, gotta spell it right. LoRas. And I don't know, let's do style 18 first. Style 18, no, style 18v2. Okay. And we're going to give it a name. And this name is something that I can define to be whatever I want. This is for us to set different preferences about how the LoRa is used later in the code. So what I want to do for this one is call it novice. Actually, no, let's not call it novice. Let's call it style 18. And that way it'll match the name of the LoRa. So the next step is to actually apply this before we do the Stable Diffusion step. And you can do that up here in the class, but if we do that, then we'll have to use the same settings for every single image that we make. And I kind of want to set up a little script that runs through a bunch of different settings so we can find the one that works the best. So what I'm going to do is set that up down here. And let's see, we want to do self.pipeline. No, thank you. Don't want that. I want to do set adapters. Is it set adapter weights? No. Set adapters. Yeah. Except that's not right. See, this AI is just not smart enough for this. All right, so we need the name of the LoRa, which is what we say here. And we'll be able to load the weights from multiple models and then define a ratio between those LoRa for the image creation. But one thing at a time, I just want to see this one. So we want to do adapter weights, and we will set it to 100%, which is 1. And there's one more step that we have to do, which is right here. And what we want to do is set the cross attention keyboards. No, not number of heads. We want scale. And we're going to set the scale to 1. Now, the default is scale 1, but I like to add this anyway just because it's explicit. And if I wanted to change it, we could. But I'm going to go ahead and hardcode 1 there for now.
Okay. And just to track back, we could have added that LoRa's parameter. That's a list. We could have added like multiple LoRa's.
Yeah, what we're going to
Okay.
do is we're going to add this other LoRa right up here, which is, we do it the exact same way that we did this. We get a different name, and then in this step, we can specify an adapter weight for each of them separately.
Okay.
Yeah. And this weight is not the same as this weight. So we can set the individual weights of the LoRa's here, and this is the overall weight of the composite of the two LoRa's. Right?
Okay.
So there's a couple of different knobs there, but let's go ahead and see this at full strength first. Oh, one other thing I'm going to do here is num inference steps. We're going to set this down to 30. By default, it's 50, and it takes 23 seconds per image. I don't think we need to spend quite that much time on these. We'll see. What did I do? It's having trouble loading the LoRa. Oh, I know what I did. All right, so I specified LoRa's in a file called main inside a package called app, right? So this main is running inside app, right? So its root is app, and there's no LoRa's directory inside of there, right? So there's a couple of different ways to handle this. Either I can specify that I want to go up a level before we get to the LoRa's, but I hate that syntax. I want to do something a little bit different. I'm going to go to the configuration in PyChart. All right. So right here, I can specify for the main.py file that I want its root to be the root of the project rather than the package it's in.
Okay.
And what this is going to do is allow it to find the LoRa.
Okay.
So I'm going to run this over again. All right. So we shaved, I don't know, 6 or 7 seconds off of that by reducing the number of inference steps.
Awesome.
Now, there is another difference here, right? The original image that we created is inside app, and now the images are being created at root, which is a direct result of changing that configuration.
Okay.
So I'm going to go ahead and look at that. I'd say that looks a lot more like a kid drawing. It's still a little too good. There's a horizon line. The lines themselves are actually done with a certain level of confidence. It's not shaky like kids' drawings usually are, but we're way closer than we were originally, right? So just for comparison, let's go ahead and look at that. I mean, this hash marks, that kind of looks like a professional artist did that, especially the way this face showed up. That's way too good.
Yeah, there's a lot of depth there.
And just to be clear, the motivation for making it look worse, lower quality, is that we don't want the bots to beat the kids. We want the kids to beat the bots, right? So that's my motivation for trying to make this look less good. All right, so let's go ahead and define our second LoRa. And graffiti. underscore v1. And I'm just going to comment this one out for a moment.
This is pretty cool. It's like there's the sort of coding requirements, but then there's also like a game balance sort of thing that you're dealing with.
Yeah, yeah, definitely.
That's cool.
Okay, so I'm gonna go ahead and change that. And now we're using this other LoRa just to see what it looks like. All right, so there's the first one.
Hmm.
There we go.
Oh man, that's awesome.
Now we're talking. Okay, so another goal of this project is to be able to match a grade level of these bots, right? So at the lowest grade level, which I think is fourth or fifth grade, it's like 8-year-olds, we want it to look pretty much like that. And then at the higher grade level, where they're 13, 14 years old, we want it to look more refined. Probably not quite that refined, though. So,
Hmm.
in order to get that blend or that spectrum of ability, we're going to
Hmm.
blend between these two LoRas.
Oh wow. Okay.
Okay, so I'm going to turn them both on, and we need to specify the second one in here. And we need to provide a weight for each. And I'm actually going to start off with 50-50,
Okay.
just to see what we end up with. I think this is going to be really close to what we want for the highest grade level, but let's go ahead and see. I'm going to move this image out here, and I'm going to create a new directory called output just to keep these images nice and neat.
Awesome.
The other thing I need to do is make sure that we have output defined in our save. Now, I'm probably going to parameterize that later, but for right now, this will work.
Gotcha.
All right, let's see what this looks like. Now, notice that this takes a little longer. Using LoRas, especially using multiple LoRas, makes the generation process take a little bit longer. Not too
Okay.
bad, though. Just a couple of seconds longer in this particular case. All right. That's not bad.
Hmm. Yeah.
It's got some of the shading that looks nice. The lines are confident, but not too confident. They're shaky, but not too shaky. I think that works for the highest end.
Yeah.
I'm actually going to end up showing the client various ratios between these two LoRas and let them decide what to do.
Gotcha.
Um,
Okay.
so let's see. Yeah, this one is the lower quality one. This one's the higher quality one. Let's do one where it's mostly the lower quality one. So that would be this one. And we'll just do a 75 to 25 split. I'm really just kind of exploring what I can do with these models.
Hmm.
I don't know what ratio or what group of ratios the client is going to synergize with.
Gotcha.
But I think we're really close. Let's see what we got here. Is that the one that we just made?
No, I don't think so. Oh, I think it's that one, right?
Yeah, that's pretty good.
Yeah, that's cool.
The prompt coherence is better at the higher quality than it is at the lower quality, right?
Hmm. Mm-hmm. Seems like it.
I think I'm going to call it here. If you'd like to play with this code, I'll go ahead and post a link to the GitHub project.
Yeah, that'd be awesome.
I probably won't get to that right away, but in about a half an hour, go ahead and check the Silicon Society page, and I'll provide a link to this
Okay.
project there.
That was awesome.
You will have to download the LoRas individually on your own because I don't want to put those up on GitHub.
Sure.
But you should be able to get any LoRa that's built for Stable Diffusion 1.5 to work, and there are hundreds of thousands of them. I may even go hunting for some more, but I think this works for MVP, and yeah,
That's awesome.
I'm stoked.
Thank you, Robert. This was really cool. Just to track back a couple of things, like, okay, so the IDE that you're preferring is PyCharm. That's
Uh-huh.
just your preference. The LoRas are kind of like, I don't know, sort of tuning objects, or like, how would you describe the LoRas? Are they
They are plugins for the model.
plugins for the model? Okay.
Yep.
Okay.
It's not the same as fine tuning.
It's not the same as
It's different than that, which is why
okay.
I'm steering away from that terminology.
Copy that. Okay. This was really cool. Oh, and just the requirements file, just to track back why you prefer the install shell script. You said you prefer it, but is there a specific reason that you would do that rather than just run it like, I don't know, in a terminal or something?
Fundamentally, it is exactly the same as running in a terminal.
Hmm.
The reason that I prefer doing it this way is because I don't want to type all that every time I do an install.
Gotcha. Okay, gotcha.
It's kind
Okay.
of laziness, but at the same time, I get this right once and I never have to worry about any typos after that.
Absolutely. That's a perfect reason. That's great.
Not
Okay.
only that, but I often work with junior developers and I
Mhm.
like providing stuff like this for them to see how I do stuff.
Perfect.
This one is a pretty common pattern, but I also do shell scripts for other things that are not common. And some of them are really short, but the reason that I make shell scripts out of them is to share the information of how to do certain things.
Got it. Okay,
Yeah.
copy that. Okay, and then the git ignore, you said you got that from a template that you had already previously?
No, PyCharm can make that for me.
Oh, okay.
So but PyCharm has a template for it.
Got
Um,
it.
this one in particular is specific to ignoring these IDE files, which are a PyCharm thing, and then it has, the operating system files in here, and just all kinds of different things that could be present in here that you wouldn't normally want. Um, and then
And
I
then you
add
just added
custom things myself at the very bottom. Yeah.
perfect. Okay. Okay, thank you, man. This was
Yeah,
great.
absolutely. My pleasure. Thank you for joining. I'm happy to have you here.
Yeah, this is really cool. I look forward to more. And this is definitely my first experience with, I guess this is an image generation model.
Correct.
So yeah, this was super cool, man. I'm excited. All right. Thank you, Robert.
All right. Just so you know, there is
Mhm.
Stable Diffusion XL out there and
Huh.
even some other types of Stable Diffusion. This is actually the worst quality one available. I selected it in particular because it's fast. And the quality is such that this level of quality is actually what I want.
Right. It works for the game, man. That's
Right? It
awesome.
works for this, where I would probably never use this for situations where I need good quality.
Yep. Cool. All righty.
Okay,
Thank you,
thank
sir.
you, Earl. We'll see you.
Yep.